Welcome to episode 3 under Primer Series. In this, we are answering how can AI understand a sentence. Here so far we have completed the Colab part, that is your notebook and first cell, and Python we have covered variables, list, functions, and today we are going to cover the vector part, that is just dimensions and the numbers. And finally we'll end with similarity in this series. So I'm super excited. Let us go inside. The computers only understand numbers. They don't understand images. They convert into the pixels, finally numbers. They don't understand text. They convert to that characters, again finally numbers. And in case of audio, again samples, finally convert to the numbers. AI doesn't think in English. AI think using numbers. But what are those numbers? Which are a vector. Let us start with simple vector in a dimension 1. You are finding a treasure. It is simply on the straight line of the road, around some 12 kilometers from here. So here we just only need one number. 12 is sufficient to find the treasure. But if the treasure is in a house, and the house we have to look out in the map, so then the single number is not sufficient. We need some coordinates, latitude, longitude. So these are the two coordinates, and here we have 8 kilometers. You go straight and take left of 5 kilometers, something like that. So you will arrive at the house. Now we add one more dimension. This is dimension 3, that is height. You are having some 5 floors. The treasure is on the 5th floor. So you need one more coordinate, that is floor. This is, in this case I have given example of 3, that is in the 3rd floor. Now imagine the treasure is inside a building. We start with 8, 5 for the house, and we have added 3, that is on the 3rd floor of the house, and we keep adding some more features, like after going to the floor, it is in the which room, then again under which room, again cupboard. Like that we are going very granular way. Then we arrive at the 384 numbers. Nothing magical happened. We simply kept adding numbers, each one storing one piece of information. This is called a higher dimensional vector. Exactly the same thing ChatGPT does. From toy example to the real AI, I love cricket. Then it's sent to the embedding model. This I love cricket is converted into 384 values. So initially it may be 0.12 minus 0.41, like in our the treasure example. The MiniLM reads a sentence and produces 384 numbers instead of English. No single number means anything alone. In our example, it is house coordinates and again floor. This we are able to clearly define for the example purpose only. But these numbers, individual numbers are nothing. Only the group of numbers means something. Together they represent the sentence. In this example, I'm adding more sentences. Vector A, I love cricket, and vector B, simply I changed one word, I like cricket. For humans, we know that both are similar, but whether computers knows, because for vector I love cricket, it produces some numbers, and I like cricket, it produces numbers which are closely near to vector A. So that is why they are close together. You take another example, I hate vegetables. This is completely unrelated. Then it produces some numbers which are very far. Just here is the AI places similar ideas close together and different ideas far apart. But how does it measure close? That will cover in the next session. That is vector A and vector B similarity. That is something called cosine similarity. We are going to cover very shortly. Here we are using the sentence transformer. We are utilizing the LLM all MiniLM L6 version 2. It uses 384 dimensions. We are giving the sentence I love cricket, sending this sentence to the model, and it prints the length of embedding as 384, and first 10 values we are producing like 0.183. These are 3 sentences, 3 vectors. How to compare them? That is the next in the series. So let us go to the live demo. I have already pre-filled to save your time. So this is, in this I have used the GPU, T4 GPUs. I'm executing the first, I'm importing the library. So it is taking some time with GPU also. It is finally executed. Now we are calling the model and passing the sentence and encoding that. Now you see the weights will be loaded. Everything is completed. Then what we do is print the length of the embedding. If everything correct, it should show 384. Perfect. Then we'll show the first few embeddings. Yeah, you see here, if I show the entire embeddings 383, if I use, then produces some big number. So you see how big the number is. Individually it is nothing, but together it is the sentence. Now I like cricket, I use. Let us see whether it is producing. I'll make it again 10. Just we'll do little experiment. 0.032 I got initially. If I use I like cricket, do I get something same? Then I'll directly go here 0.032, 0.004. So now I hate vegetables. We'll see what happens. Here let us see, first 2 are positive, next 2 are negative. 0.004, 002, what happens? We'll see. It is again something random. So we cannot know based on the first few things. Everything we have to see. That is about the demo for today. What we understand is it is converting each sentence into the numerical representation in the higher dimensional space of 384. we have produced some numbers that only computers can understand. Individually, we don't anything. Together, all these 384 dimensions represent one single sentence. So now we understand how AI understands. It is not images, text or audio. It is just numbers. So far in the primer series, we have covered Colab, Python, vectors. I'm super excited to cover similarity. Let us meet in the similarity. If you like this primer series, please subscribe and like and comment. See you in the next primer. Thank you. Peace.